Welcome to today's webinar, Radware and Big Switch, a customer case study on programmatic DDoS mitigation. My name is Sharon Fitzpatrick, and I will be your host for today's webinar. Our speakers for today include two Radware security solution architects, James McGrill and David Jimenez. Bala Ramachandran, the Senior Director of Product Management at Big Switch Networks, and Ashutosh Alawani, the Technical Marketing Engineer for Big Switch. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, or if you have questions on an upcoming webinar topic that you would like our panelists to address, email us at info@bigswitch.com. Before we get started, I'd like to open it up with a poll. So you'll find that a poll will come to your screen, and what we want to do is really understand what kind of solutions do you have today for addressing DDoS attacks. Do you guys on the panel want to address as to what you think the answer might be? Which one's going to be the winner?
I feel that it's probably going to be a spread across some of these options, especially the options for cloud service, on-prem. A mix is what I expect. Okay.
David or James, do you have an opinion?
I think it will be pretty much across the board. In some cases, it would be even two options, cloud and on-prem, for more of a hybrid strategy. But I think that the answer will be an even spread amongst all options.
Well, great. Let's close it and figure out. So it is actually not on-prem is only 17%, but I use an internet provider for DDoS mitigation is 33%, or I use a cloud service for DDoS mitigation. So those two are tied, and the other two are tied at that point. So, so at this point, I'm going to turn it over to James and David. Go ahead.
Excellent. Thank you, Sharon, for the introduction. Hello, everyone. As Sharon stated, my name is James McGrill. I'm a security solutions architect. I help enterprises, service providers, and carriers design and implement cost-effective, next-generation security frameworks. I'll be giving a short product overview specifically focused on DDoS detection, DDoS mitigation, and how Radware integrates with vendors such as Big Switch Networks by leveraging Radware's DefensePro orchestration. Today, the Radware and Big Switch teams will show you how to automatically detect and mitigate DDoS attacks without manual intervention, without the use of NetFlow, and without the use of BGP to divert traffic. So to kick things off, I'd like to start by delivering a summary of Radware's security portfolio. So not only does Radware provide on-prem and cloud DDoS services, but we also deliver market-leading security services such as WAF, anti-bot, and our own threat intelligence feeds, delivered through our purpose-built deception network, which rolls up all of our big data analytics from our own cloud. In short, we do more than just DDoS, which leads us to Radware's core elements. All of Radware's security elements, whether an on-premise appliance such as our DefensePro, capable of mitigating up to 400 gig of DDoS attacks within a single 2U appliance, or our cloud DDoS service, capable of mitigating over 5 terabits of DDoS attacks, is backed by our 24/7 emergency response team of security experts. So let's shift our focus back to Radware's award-winning DefensePro. DefensePro is a real-time attack prevention device that protects your infrastructure from the next generation of DDoS attacks, application vulnerabilities, exploitations, and network anomalies. The DefensePro is built on 5 main protection layers. Let's take a look at those 5 protection layers. The first is behavioral analysis. This focuses on the ability of DefensePro to dynamically learn traffic patterns and automatically mitigate attacks in real time, such as burst attacks and DNS amplification attacks, such as the Mirai botnet. Next is the challenge and response mechanism. This validates the good guys from the bad guys through a series of escalated challenges in order to further weed out false positives. Think of this as your countermeasures. And we have access controls. These are well-known security measures DefensePro employs to perform such actions as rate limiting, connection limits, whitelists, and blacklists. Next are known vulnerabilities. The DefensePro carries a local IP signature database to prevent against well-known attacks. And finally, we have threat intelligence. DefensePro receives real-time threat intelligence from our global cloud infrastructure on the bad actors that are actively attacking at that moment in time, so the DefensePro can block them immediately. So to summarize, the DefensePro utilizes well-known security defenses such as IPS, ACLs, rate limiting, but more importantly, the DefensePro layers on behavioral analytics in order to minimize the false positives, and it consumes threat intelligence to block active attackers in real time. So with that said, I'd like to expand a little deeper into DefensePro's behavioral technology. But to understand the difference between rate-based technologies and the DefensePro's behavior-based technology, we first need to understand how rate-based technologies work. In essence, rate-based technologies simply rate limit the traffic. The rate is set either manually or possibly learned over a period of time. In any event, it's still a fixed inbound rate. And if the traffic bandwidth exceeds that set rate, whether it's clean traffic or attack traffic, it doesn't really matter. It's simply dropped. The problem here is that good traffic is discarded and attack traffic is leaked through. In contrast, the DefensePro implements a patented rate plus rate invariant technology. This ensures that when DefensePro baselines traffic, it doesn't only track on inbound traffic rate, but it tracks on rate invariant parameters as well, such as TCP flags, DNS queries, record types, domains, and 20 other parameters. In short, the behavioral technology limits false positives, such as knowing the difference between a successful marketing campaign and a real DDoS attack. And the DefensePro minimizes the required effort of the operator to have to manually write signatures and constantly tune the device. The real beauty here is the automatic signature creation, which takes us to the next slide. So if I expand a little further on that point, the DefensePro automatically writes signatures for unknown attack types in under 18 seconds, whereas manual intervention could take anywhere from 30 minutes, if you actually know what you're doing, to a few hours, depending on how many devices you actually have to deploy them on. The bottom line is that automation is the key to detecting and mitigating in real time. So now that we understand how to mitigate attacks in real time with DefensePro, how can Radware help you integrate these capabilities into your infrastructure in a more dynamic fashion? The answer is DefensePro, which brings us to the next slide. So what is DefensePro? DefensePro is a centralized cybersecurity controller. It's an orchestration system that fully automates workflows based on business requirements. It allows Radware's security stack to integrate seamlessly with other vendors, such as Big Switch Networks. This is accomplished via the cyber control plane. So what is the cyber control plane? Well, first we should determine what the data plane is. The data plane is typically any device that is sitting in the data path. These are devices such as switches, routers, mitigators, and servers. Most of these devices have a limited view of the topology at best and are usually hardware-based. Now that we have a basic understanding what the data plane is, we can focus on the control plane. The control plane sits outside the data path, and we'll have more awareness of the entire network topology across all layers. This brings us to DefensePro, which sits in the control plane and acts as the cybersecurity gateway. DefensePro will consume, relay, control, and telemetry protocols such as BGP, FlowSpec, NetFlow, syslogs, REST, and so on. But how does this help you in your everyday life as a security expert engineer? The answer is automated workflows. You can create automated workflows to perform security actions as you wish. Imagine that your network's under attack. DefensePro can receive an alert or a trigger from any detector. And once DefensePro consumes that trigger, it will perform any action that you define. This could be a custom action, such as scrubbing traffic locally on a DefensePro. But what if the attack escalates and starts saturating the physical link? No problem. You can configure DefensePro to perform another operation when that condition is met, such as divert traffic to, say, a scrubbing center. like an external scrubbing service. Or maybe you have a third condition when matched will perform an action such as remote trigger black hole or flow spec. The concept we'd like you to walk away with is that the flexibility of DefensePro allows operators to perform custom security actions and workflows based on your requirements. And DefensePro will allow you to integrate and use your existing systems. Finally, I'd like to emphasize the flexibility of DefensePro. DefensePro allows smooth integration with other vendors like Big Switch Networks in order to provide our customers with the most extensible detection architectures alongside the best mitigation device, DefensePro. So with that said, I'd like to pass the presentation on to my colleague, Bala, with Big Switch Networks. Bala?
Thank you, James. It was a great overview of the Radware DefensePro and DefensePro products and how they're effectively deployed to combat modern-day DDoS attacks. Now, before we go into the customer case study, that is the main topic of the webinar, and how the Radware BSN joint solution enables programmatic DDoS mitigation, let's first get a quick understanding of what Big Monitoring Fabric is all about and the key pain points that it addresses. So security has been a top priority for organizations because of the tremendous disruption and impact which security breaches have created in the past. What we are learning from our customers is that there are clearly gaps in application traffic visibility, which attackers are able to take advantage of. So it comes as no surprise in the survey results that are shown here that network visibility has been identified as the most sought after mechanism for threat discovery and also one of the top security priorities for organizations. Also, with applications becoming more and more distributed, application conversations happen across the network. So majority of the network traffic in the data center is east-west. So what this means is that gaining pervasive visibility, deep visibility through monitoring at a lot more points in the network is the best way to tackle some of the increasingly complex security issues. So putting it in simple terms, you can't protect what you can't see. And therefore, we need pervasive and deep network visibility for security and analytics. So now let's look at how Big Monitoring Fabric on-prem monitoring solution, or Big Mon for short, solves this need for deep and pervasive monitoring for security. And what are some of the unique features which enables this customer use case for us. So Big Mon is a solution that is built with the core principles of simplicity, of scale out, leverages open networking hardware with software controls. So essentially what this does with all these elements is that customers have a monitoring solution that not only serves their comprehensive monitoring needs for today, but it is also a future-proof architecture to scale seamlessly for their future needs with no change in complexity while reducing cost. So what does Big Mon do? Let's take a quick look at that. So on the left-hand side, we have the production network, and this could be a network from any vendor, any topology, different kinds of workloads, virtual machines, and so on, or bare metal workloads, and so on. And on the right side, you have the centralized tool farm. And the two sides are connected by a scale-out fabric of open networking switches in the center, which acts as a single logical big switch, hence the name of the company, Big Switch. And this is managed by a single pane of glass, a pair of SDN controllers, which are called Big Mon controllers. And this whole unit, the controllers and the fabric, forms the network packet broker in the middle. So essentially, the copy of traffic that is sent from the production network via tap or span are processed and sent to one or more tools on the right-hand side. And this is achieved by the user defining rules to filter, aggregate, replicate, load balance traffic to the appropriate tools in the tool farm, all from a single pane of glass, the Big Mon controllers. So the key thing to note here is that the management complexity is bounded to a single logical switch, irrespective of the number of switches in the fabric. Now, the other important point to understand is that the BigMon controller exposes REST APIs to enable dynamic operations on the fabric. For example, to dynamically program policies and visibility. Now, advanced packet functions like deduplication, header stripping, net flow generation are all done using service node, which is a DPDK enabled industry standard x86 appliance. Now, this is integrated with the fabric and again managed by the same controller. Now, the BigMon capabilities can be further augmented to provide, packet capture using a recorder node that we have recently introduced, and advanced analytics using analytics node. Now, both of these again are industry standard x86 appliances and managed by the BigMon controllers. So in this way, the BigMon fabric, controller, the service node, analytics, and recorder node all work together, and they can be leveraged to create an integrated workflow for pervasive security monitoring and deep network analytics. But the key thing is all of this can be done from a single pane of glass controller. So having learned about the capabilities, let's talk about how BigMon and Radware solution has solved a specific customer use case for DDoS mitigation. Now, the customer is a large SaaS company that was looking for advanced DDoS mitigation, detection as well as mitigation. And on the left, we have listed the key requirements that this customer had. So firstly, they wanted continuous monitoring of traffic for DDoS attacks. And once the attack is detected, the ability to dynamically alter policies to divert the attack traffic. So basically, to treat and process the attack traffic different from the regular traffic. And of course, it's not just enough. If the attack is detected, it is imperative to achieve real-time mitigation of these detected DDoS attacks. So why did the customer pick the BigMon Radware solution? BigMon's ability for monitoring at various points in the network for DDoS detection based on user-selected criteria is, one of the key reasons. And then, most importantly, the Radware and BigMon together have an integrated solution that leverages REST APIs, which is exposed by the BigMon controller for dynamically programming policies for specific type of traffic. So it is this integrated solution which enables the dynamic programming, which was a key aspect for the vendor to pick the solution. And in addition, the solution offers the ability to quickly automated filtering of attack traffic diverted for DDoS mitigation in a dynamic fashion. So let's take a closer look at the solution to understand it in a little more detail. What we have is a redundant HA deployment where BigMon switches managed by the BigMon controllers are sitting in between the top and bottom routers in this scenario. Basically the top router connects to the untrusted network and the bottom router is to the trusted network. So the top routers get traffic and what we need is a bidirectional traffic flow between the two routers, and this is achieved through the BigMon controller by configuring the interfaces on the BigMon switches connecting to the routers as both a filter and a delivery interface. So you will see what I mean by this when you go through the demo, which is coming up soon. So there you will see how the interfaces are programmed as both filter and delivery interface to achieve this bidirectional traffic flow. Now, what you see here is the workflow when there is no attack. So when there is no attack and the traffic is clean, only the traffic coming from the top routers, which is basically coming from the untrusted network, is mirrored to the Radware DefensePro, which inspects the traffic to detect for DDoS attacks. So in this case, there's no attack traffic, so no action is needed. So it continuously does the monitoring of the traffic that comes from the top router. Now you can also see that the Radware DefensePro is managing both the DefensePro devices. Now let's look at the workflow when there is a DDoS attack happening. So just like the previous scenario, the traffic from the top routers are mirrored to the Radware DefensePro devices. So in this case, DefensePro detects the attack, right? So there is attack traffic that is mirrored, and then that is detected by DefensePro. Now let's say the attack is for a specific IP destination, say destination IP of 2.2.2.2 or something. Radware DefensePro, once the DefensePro detects it, it signals, and the DefensePro will make a REST API call to the BigMon controller to immediately remove that traffic from going to the span port, and instead divert that traffic to interfaces or ports dedicated to receive attack traffic. Now these are also referred to as dirty or sink ports in this picture. Now this is done by creating a higher priority policy on BigMon that matches on that particular destination IP to divert the traffic to the dirty or sink ports. Now the Radware devices then clean this traffic and then send them to the bottom routers through a separate interface that is meant to receive clean traffic. Now these are called the clean ports. So you can see that with policies from BigMon controller, we are able to really segregate these different functions and have a very clean workflow and a way of detecting and managing DDoS attacks in a very efficient manner, all achieved through dynamic programming from Radware to the BigMon controller. Now, it's also important to note that while all this is happening, the peacetime policy remains in effect. So basically, if there is a clean traffic coming through while this is happening, it will go through the same mechanism that I talked about in the previous slide. So there's no change to how the clean traffic is handled. So in summary, the integrated solution enables programmatic DDoS detection to enable the customer to not only detect but also mitigate in a dynamic and rapid manner. So with that, we come to the exciting part of the webinar where Ashutosh, my colleague here, and David from Radware will do a hands-on demo of the integrated workflows that I just described across both the BigMon and Radware products. Thank you, and over to you, Ashutosh.
Thanks, Bala. Hello everyone, I am Ashutosh Alawani and I will go over the first half of the demo. This is the topology we will be using for the demo. We have an internet user and an attacker trying to reach the internal server 4.4.5.1 via the BigMon switch. Radware DefensePro is connected to the BigMon switch for threat detection and mitigation. To begin with, we have not configured the BigMon switch and hence there is no connectivity between the outside world and the server. This can be seen by initiating a ping to the server. We have also initiated HTTP sessions to the server, and as you can see, neither the ping nor HTTP are successful. So let us start our configuration with the interfaces. We select Ethernet 25, which is connected to the internet user. Click Configure and set this interface to filter and delivery. This will enable the interface to both send and receive traffic at the same time. We now give it a name and then save. Similarly, we configure the remaining interfaces also to filter and delivery to enable bidirectional traffic flow. These would be Ethernet 26, Ethernet 10, 11 and 9. The next step is to configure the policy for traffic to flow from the internet to the server. We also send a copy of this traffic to Radware DefensePro on span port E11. To do so, we click Big Tab, Policy, and then Add Policy. We give it a name, peacetime in this case, and set default priority level 100. Under the rules, we select Any to match all traffic. We select feed as Ethernet 25, which is connected to the internet user, and for the tool, we select interfaces E26, which is connected to the server, as well as Ethernet E11, the span port. We now save this policy config. The next step is to configure the policy for the return traffic coming from the server going to the internet user. To do so, we add a policy with the same default priority. The rule would be to match any traffic. The feed would be Ethernet 26 and the tool would be Ethernet 25. We now save this policy. Now that we have these two policies configured, the external user should be able to reach the server. The ping is now successful, and so are the HTTP sessions. The blue line here denotes 200 OK from the server. Now the third policy is to divert the traffic, the attack traffic, towards Radware DefensePro over interface E9. To do so, we add the third policy. We click add policy, give it a name attack time. Please note that the priority of this policy would be higher than that of the peacetime traffic, and hence we set it to 101. We don't add any rules for this policy, as the rule will be automatically added once a threat is detected. The feed for this policy would be Ethernet 25 coming from the internet, and the tool interface would be Ethernet 9. We save this policy as well. The last policy is for the scrub traffic coming from Radware DefensePro on Ethernet 10 and going to the server on Ethernet 26. We create the scrub traffic policy with default priority, rule to match any traffic. The feed for this would be Ethernet 10 coming from Radware DefensePro, and the tool would be Ethernet 26 going to the server side. We have now completed all the configuration of the BigMon switch. Note that the attack time policy is inactive as it has no rules. Once a threat is detected, Radware DefensePro makes a REST call to BigMon controller, which then inserts the appropriate rule to divert the attack traffic. I now hand over to David, who will walk you through the rest of the demo. Thank you.
Well, thank you, Ashutosh. So I just wanted to continue on with the demo, and this is the portion of the Radware component. I'm showing you the span interface, and in Ashutosh configuration, interface 11. So filtering by interface 11, we can see that the mitigation device is inspecting about 4 megs of traffic. So switching over to the orchestration engine, we can see one specific ongoing protection for the policy that was pushed before. This is the detection policy for a specific prefix that we are monitoring. In this case, the policy name is actually called customer F. It could be any asset that we're protecting, and then the prefix that we're processing traffic for is 4450/25. You can see that we successfully pushed it to the mitigation device. So the mitigation device is actually inspecting that traffic from the spam port. Highlighting that there's no announcements, there's no diversion. We are not in path at this time, and the security device is inspecting the copy traffic and detecting anomalies out of that copy traffic. Going into the configuration of what we call the protected object. So this is the piece that we will define assets in terms of what needs to be protected. We are looking at prefix 4450/25, and we have the component that James referenced in his portion where we call a specific provisioning policy. This provisioning policy is what pushes the detection policy onto the device, plus an attack workflow rules. So whenever the anomaly is detected, we will execute what we call an operation for a programmatic diversion via REST calls. Drilling into the specific configuration for the traffic, we will see that the device is actually processing about 4 megs of inbound traffic. We will clear out the filtering for the interfaces so that we could see before and after the diversion happens of how the traffic is being processed, and expanding into the attack time policy that we configured before. Looking into its configuration, we could see that there's specifically no rules for anything that is under attack. The policy is inactive. There's no individual rules, and this is where the REST API will be made upon detection event. So if we go back to one of the machines that we have set for attacker streams, sending an attack to one of the addresses in that range that we're protecting, in this case, it's going to be 4451. We're going to send a UDP flood on port 1900 and send about 600 bytes of payload per packet. That will give us about 600-700 megs of dirty traffic or unwanted traffic. The attack has started, so monitoring the mitigation device, we could quickly see that this attack stream will be detected. In a few seconds, we will see not only that the inbound line, the blue line, will go up because we're processing the attack traffic over the span session, but we will immediately start mitigating that attack and create what we call a real-time signature to mitigate that attack based on some statistical values and some anomaly parameters that we will create this rule on. So refreshing the UI, I can see that, yeah, this is already almost to the 160 meg mark. It will continue to go up. And in a few seconds, we will see that the device will take a very short amount of time to start mitigating that attack. So looking at the red line, I can see that we're already dropping some traffic. And in the background, what you're not seeing because it happens automatically, but the device is signaling the orchestration engine defense flow. If we switch over to the ongoing protection screen that we had from before, at this point, we already executed the diversion operation. So if we take a look at the diversion operation, before it was only one entry in this table, now we have an additional detection event for 2 total entries. We can see that we successfully pushed the API call and is actually for a specific individual IP that is under attack, 4451/32. This is the piece that I would like to show you on the Big Switch controller. Refreshing the attack time policy, we programmatically insert one of these discrete IPs. It could be a /32, like in this case, or it could be a bigger prefix, multiple addresses. Really, the possibilities here are based on the API call that is being sent, and all those options have been addressed in the integration. Once we go back into the monitoring screen for traffic, I wanted to show you not only that, yes, we're processing about 600 meg of traffic, we're blocking some, but filtering only on the mitigation interfaces, you will see that, yes, this is the dedicated interface. So in here, we only see traffic destined for 4451. The rest of the traffic coming on the span interface for the rest of the addresses in that prefix that we're processing are still being protected, are still being detected. If there's a new detection event, we will be able to divert it as well. In the same fashion that we did, we will just create another entry. Going into the forensics and analytics for the mitigation device, we can see that, yes, the traffic is being displayed. We're dropping some. I could see a spike in the connections per second and also concurrent connections because of the unwanted traffic, but very quickly we were able to restore the service to normal levels. Drilling into the specific policy, we can see attack and drop rates of what the attack looks like. If we drill into this specific ongoing event, we can see how we're blocking it. So this is what internally the box also programmatically includes these parameters and sequentially goes into what is an anomaly and what defines the real-time signature. So we're blocking the attack, we capture a few drop packets, some attack sources, and we also indicate what kind of traffic stream is causing the anomaly, in this case, UDP traffic. Going back to the attacker, I would like to show you also how we clean up these rules. We keep track of these attacks. So stopping the attack and then just going back into our statistical dashboard. we will see very quickly that the attack, of course, is going to stop, and the levels, legitimate traffic levels, are going to drop. I'm sorry, the attack levels are going to drop, and the legitimate attack levels are going to be evident in the graph. In a few seconds, we will see changes in the graph, and we will also see that once the mitigation device stops detecting that there's an anomaly condition, we will be able to signal the orchestration engine. Before we do that, I wanted to show you the impact of the legitimate traffic. So looking at this tool, we were sending HTTP requests, and you could see the dip, the drop in the number of HTTP requests when the attack was happening. We went all the way down to below 20. And this only happened for a few seconds, I would say. We were able to quickly restore the service to a legitimate amount that we would have before the attack. I could see that the attack has already dropped and it's being registered as not an anomaly condition. And now what we would like to show you is the ability for also to clean up these rules and keep track of these attacks. Going back into the Big Switch API, we will see that is specifically going to be removed. So monitoring the Radware component and going back to the previous place where we were monitoring these ongoing protections, we will see very quickly that the attack and the entry will go away on its own after the specific grace period happens. So in this case, we have two entries. Very quickly, we're going to see after a specific timeout, we will see that the second entry will go away. We will clean up the REST call. We will issue a new REST call, and we clean up this diversion, temporary diversion that we had for 4451, and remove the rules that were added to the specific Big Switch policy. As you can see now, we've removed the entry from our end. And if we switch over to the BigMon controller UI, refreshing the peacetime policy, the attack time policy, we could see that these rules are no longer there. You could also see that the policy goes into an inactive state because it has no active rules. So in this case, we effectively remove the diversion and the assets still being protected. Now with this, I would like to turn it back to the Big Switch team for a quick wrap up. I hope that you have enjoyed this demo, and I wanted to turn it back to the Big Switch team for some wrap ups and also to address any kind of questions that we have.
Was great giving us a demo. I just want to let folks, we've gotten a couple of questions about, do we have this session recorded and will it be shared? The answer is yes. You will get an email with a link to the recording. So that makes it perfect. Here's a question. Why couldn't I use a span port from my router to send copy traffic?
Yeah, absolutely. And this is David from Radware. We can definitely use the span ports, and this is a common scenario. The advantage of using a Big Switch infrastructure and then the integration that we have is that we will be able to filter the attack traffic out of the span, and the mitigation device wouldn't have to process the same traffic stream twice. So you will be able to send a copy, and not only send a copy of the traffic, but programmatically tell it that whenever there's the attack for a particular destination is being mitigated and diverted for mitigation, then we wouldn't have to send it for the copy port and avoid processing duplicate traffic.
Great.
Yeah, I just wanted to add to that. Thanks, David. One of the main reasons why the customer chose this solution is, the ability to do, multiple of these operations, in a programmatic fashion by leveraging BigMon controllers REST APIs. So that's a very key differentiation that really appealed to this customer. So which is why this solution is very powerful.
So is this a redundant solution?
Yes, absolutely. It's a redundant solution across all the different layers, not only the Big Switch infrastructure, but also Radware, the orchestration engine, and Radware, the management components. And I believe it all applies to all the layers across the two different components of the solution, Radware and Big Switch.
James, let me give this one to you. Would I be able to integrate this solution with the cloud mitigation service?
Yeah, yeah, exactly. What I was talking about a little bit earlier was some of the features of obviously DefensePro being able to signal, say, for example, Radware's DDoS cloud. So if you're having an attack on-prem and your pipe's getting saturated and you want to be able to divert to our cloud automatically, you can use DefensePro to do that, to automate that process. Yeah.
So maybe you can answer this one as well. Would I be able to leverage my existing Radware deployment for integrating with Big Switch monitoring fabric or vice versa?
Yeah, I think the answer is yes. Would be good to take a look at the infrastructure. We'll get an engineer on it, but the short answer should be doable. Yes.
Yes, as far as big monitoring fabric is concerned, it seamlessly works with Radware tools, and the REST APIs are open, and we are today we have this as an integrated solution, and Radware software has this capability to call the Big Mon controller REST API, so it should work seamlessly. But as James mentioned, it would be good to look at the specific customer scenario.
Absolutely, and this is David from Radware. I would just want to reinforce the fact that yes, absolutely, it would definitely be possible. We definitely need to take a look at the components, and then just look at the different versions. We added capabilities for this type of orchestration and embedded the Big Switch API into our product so that the integration is complete and we're able to integrate it. Our API is also open, and we expose it freely for anyone that would like to use it for orchestrated mitigations, onboarding customers. So absolutely on the same page with the Big Switch team, where both APIs are open, and we natively included those specific supported calls inside the product so that the integration happens seamlessly.
So I have this, and I'll make this our final question because we're running short on time, is, okay, I'm interested. I want to get started. How do I do it?
Well, please contact the sales team, Big Switch sales team. Go to our Big Switch page, try out the labs. I think you'll have more details on that, Sharon. And I'm sure the Radware sales team can be contacted too to get more information. And you can visit the websites for more collateral and any details on each of these products.
And I will let you know it's info@bigswitch.com is our email, and we'll be glad to forward it to sales. We make it really easy to get started with Big Switch products and solutions. So a good place to start, as Bala just said, is with Big Switch Labs, which is a great way for you to kind of get started with the product. You can take it for a test drive, you can figure out how it works in your environment, and it's a great way to kind of maybe start a proof of concept if you need it, and then use that as a great roadmap for where you want to go next. We also have a really robust catalog of webinars. You just need to go to bigswitch.com/webinars, and you can access them on demand, or you can visit our YouTube channel. At this time, we're done with today's webinar. I want to thank you all for coming, and thank you to our speakers, and have a great rest of your day.